Hello, my name is Leo. Today we're going to talk about trigonometry. Trigonometry is a branch of mathematics which studies relationships between sides and angles of triangles. And trigonometric functions are an important part of trigonometry. And we'll observe them firstly in xy coordinate system. So first we have unit circle, which is circle with the radius of 1 unit, and it has its center at the origin point, point O of the coordinate system. We have this angle T, which is angle between OP straight line and positive part of x-axis. First step is to construct this straight line AQ parallel to the y-axis. And now point P is intersection of unit circle and this OP straight line. So let's define trigonometric functions in this example, in xy coordinate system. So point P has its coordinates x and y. X coordinate of point P is cosine t, and y coordinate of P is sine t. Cotangent t is this line segment km, and tangent t is line segment, so it's length of line segment AQ. And they are all positive in this case because they are all in the first quadrant, as we can see. If they were, for example, in the second quadrant, cosine would have the negative and cotangent and tangent also the negative sign, but sine would be positive in the second quadrant. And we have also some situations for the third and fourth quadrant of coordinate system. We can also observe and define trigonometric functions via right triangle. Here we have right triangle with the right angle in vertex C, and where A and B are catheti and C is hypotenuse. We have here these four basic trigonometric functions: sine, cosine, tangent, and cotangent. For example, we pick the vertex B, and beta is angle by the vertex B. Now sine beta is B over C, meaning opposite cathetus over hypotenuse. So point B has opposite cathetus B and adjacent cathetus A, and C is hypotenuse always. Cosine B is adjacent cathetus over hypotenuse, tangent B is opposite over adjacent cathetus, and cotangent B is inversely, so adjacent over opposite cathetus. Here we have basic relations between the trigonometric functions. For example, we have the first one, which is the most important one. So sine of some angle, for example, angle beta squared plus cosine of beta squared is equal to 1. And here we have these two formulas for sine and cosine beta derived from the right angle triangle we've seen on the last slide in the last example. And we get that one. We have also this second relation where B over A is tangent B, which is equal to 1 over cotangent B. And we have also the inverse situation that cotangent B is beta is 1 over tangent beta. And here we have these two also relations for tangent and cotangent beta. Even and odd functions, we have also trigonometric even and odd functions. An even function is every function which for every x and minus x in its domain, in domain of that function f of x, has this identity. So this identity is true that f of x is equal to f of minus x, and its graph of even function is always symmetric with respect to y-axis. So left and right part are the equal. A function is odd if for every x and for every minus x of domain of f of x function, this identity is true, so that f of x is equal to minus f of x. And this graph is symmetric with respect to the origin point of coordinate system. Here we have a general expression for all trigonometric functions, where are here some of that parameters like a, b, c, and d. A is amplitude, B is circular frequency, also marked with omega. T is a period of some function, trigonometric function f of x, which is a proportion of the basic period of that trigonometric function and circular frequency. Basic period for cosine and sine is always 2 pi, and for tangent and cotangent always pi. Minus c over b is this translation in x-axis direction, or also called phase, phi. And this is translation of f of x function in y-axis direction. Here we have example of a trigonometric function, for example sine function, and it's f of x. First step is to recognize all of the parameters a, b, c, d. Amplitude is 1/2, b is here circular frequency, c and d, which is translation of f of x graph in y-axis direction. The second step is to calculate t, which is a period of function. Sine function has basic period of 2 pi, and that 2 pi is divided by b equal to 1, so it is 2 pi, and minus c over b parameter. And finally, we now construct this sine function in xy coordinate system. The first step is to construct straight line y equal to d parameter, which is here y equal to 3, which is parallel to x-axis. And now we have that p, which is this minus c over b parameter. So we have p, y equal to p straight line, because the whole function was translated to p to pi right. If there was minus pi, for example, we would translate the whole function graph to pi left. But here is for plus pi, so right. And now we have period of that function 2 pi, so pi plus 2 pi is equal to 3 pi. Now we have these two straight lines, pi and 3 pi. And finally we have amplitude of the function 1/2, which means that we have here this straight line y equal to d equal to 3. We go to 1/2 up and 1/2 down to get these two straight lines. And now we have sides of this of this rectangle. So now we construct this basic period. In this period we construct sine function, but it is infinite function, so we have to continue it to both left and right side of this rectangle. And here we have these trigonometric functions graphs. They're all in their simplest form, so sine of x, cosine of x, tangent of x and cotangent of x. And here are they for you to see their forms. And it is important to notice and say once more that the basic period of sine and cosine function is 2 pi, and for tangent and cotangent is only pi. Complementary and supplementary formulas are formulas regarding these angles which are in unit circle. Complementary angles are angles which are summed up to give 90 degrees equal to p half radians. So these two right triangles represent these two angles, t and p half minus t. The blue one is also always t. In the first case, this green one has angle of pi half minus t, and in the supplementary formula case we have the green one, which is pi minus t. So we have here that two cases. And supplementary angles are two angles which are summed up to give p radians, meaning 180 degrees. And it is important to say that these two, blue and the green one triangle, are the congruent right angle triangles. So we can observe their their trigonometric proportions, as we can see in these expressions. Here we have a law of sine and cosine, and both laws can be applied to any arbitrarily chosen and constructed triangle. For example, as we can see in the picture, a triangle A, B and C. And R is this radius of a circle which is circumscribed to this triangle ABC. Law of sine we have here, and law of cosine is this second law. area of triangle is the another use and apply of trigonometry in geometry. And trigonometry has many other applies in geometry and in other fields of mathematics and in the other sciences. But here is, for example, area of triangle. We know that the basic formula for the area of triangle is 1/2 of some side of triangle times height on that side. For example, 1/2 of A times height on A, which is on this first picture on the left hand side. And here also the second two more formulas for area of triangle on these two more pictures. And from trigonometric relations we have this, we can get that height on some side of triangle, for example height on A, h on A, is from this blue triangle from the first picture is b times sine gamma, which we've got from this blue triangle that sine gamma is height on A over B. So the final area formula for area of triangle using A side and height on A is 1/2 of A times h on A, so height on A, which is b times sine gamma. Now you've learned about trigonometry and about the basic trigonometry functions. Thanks for watching and stay with us.